Hello, friends. I am Satish Lele. I am a chemical engineer. I am working in the field of piping for the last 30 years. This video is part of my chemical process piping channel on YouTube. This video is about pneumatic or mechanical conveying of solids. Mechanical conveying is done by 4 ways. Pneumatic conveying is done by bag filters and cyclone separators. We will see these one by one. In an online bag filter, bags operate row by row, even when the dust-laden gas is filtered. The sequence of cleaning is controlled automatically by a sequence controller. This operates the assembly of solenoid and pulse valves which direct the airflow into the manifold. The holes are drilled for perfect alignment with the venturi center for achieving maximum cleaning efficiency. Advantages of the low-pressure cleaning system include lower pressure drop across unit, lower consumption of cleaning compressed air, longer filter bag life, lower noise level during operation. Advantages of low-pressure cleaning system also include highly efficient and quick pulse of cleaning air, lower pressure drop of cleaning air due to elimination of bend in pulsing system and effective flushing of dust. Advantages of low-pressure cleaning systems also include that it effectively flushes bag and reduces redeposition of fine dust. Can clean bags up to 10 meters long. Cleaned internally with filter media to have lower longer-term pressure drops. Filter media is not flexed as extensively as in conventional cleaning, increasing life. Hopper entry can be of the types: regular hopper entry, twin train or extended hopper, casing entry, and pre-separator casing with baffle. Regular hopper entry. The pulse jet bag filter in its most rudimentary form consists of filtration elements encased in housing. Below this casing is a hopper with a discharge valve to remove the dust that is collected on the bags. The entire unit is supported from the ground on structural legs. The cage ladder provides access to the top of the unit for maintenance. Dust-laden air enters through the hopper by suction normally on positive pressure. The heavier dust particles fall off at the entry itself, while the lighter dust gets carried upward to the bags. The dust gets deposited on the outer surface of the bags and clean air moves out from the center of the bags and escapes out from top air outlet. This is known as filtration. The dust collected on the outer surface of bag is removed in a predetermined cycle by a momentary pulse of high-pressure compressed air. The compressed air moves from an air reservoir or compressed air header via the particular pulse valve into the compartment manifold and then into the bags, in the row beneath it. Due to the pressured entry of compressed air into the bags get inflated. Thus the dust is collected on the bag as blades falls down. Soon the bag comes back to its original position and the cleaning process is completed. Dust blades fall from the sides of the hopper and slide into the rotary airlock valve. As the valve travels clockwise, the dust trapped in between the vanes gets discharged from the opening below. Twin train extended hopper is the online twin train type of unit. The dirty gas enters the common inlet clean, formed as a valve between the two filter modules. From there it flows to both the modules, and undergoes filtration as in the regular unit. The cleaned gases travel back to the common outlet cleanings of the individual clean air planes, and then flow out through the outlet duct to the induced draft fan. Casing entry. Here the dirty gas enters the casing through the inlet cut bypass damper, is applicable into a central chamber formed by perforated sheets. The gas flow towards the bags is partially upwards from below the sheets and partially through the perforations, ensuring the separation of heavier dust and better gas distribution respectively. The lighter dust gets carried upward to the bags. This gets deposited on the outer surface of the bags and is removed by a predetermined cycle by a momentary pulse of high-pressure compressed air as in the typical hollow entry type of bag filter. Pre-separator casing with baffle, as the cement industry has started installing bigger sized cement plants. Conventional bag filters have been found to be inadequate to handle large gas flows in excess of 600,000 cubic meters per hour due to severe limitations like high gas flow per bag, high velocity of gases through bag filter, higher pressure drop across filters, high space requirement due to bigger size filters and high compressed air consumption. Cyclone separator is a high-speed rotating airflow is established within a cylindrical or conical container called a cyclone. It flows in a spiral pattern, beginning at the top right end of the cyclone and ending at the bottom narrow end before exiting the cyclone in a straight stream through the center of the cyclone and out the top. Larger or denser particles in the rotating stream have too much inertia to follow the tight curve of the stream and strike the outside wall, falling down to the bottom of the cyclone where they can be removed. In a conical system, as the rotating flow moves towards the narrow end of the cyclone, the rotational radius of the stream is reduced, separating smaller and smaller particles. Boiler can be of two types: induced draft and forced draft. These have large air handling capacities. These can achieve low vacuum. Hence these are used in pneumatic conveying. Induced draft fans are used to create a vacuum by negative air pressure in the system or stack. Centrifugal boilers are used to maintain elevated ventilation, resulting in increased system efficiency. Extractor fans are typically heavy-duty construction to handle particulate in the air stream. In the boiler industry, induced draft fans are often used in conjunction with forced draft fans to maintain system pressure which is slightly lower than ambient. The purpose of forced draft fans is to provide a positive pressure to a system. This basic concept is used in a wide variety of industries, but the term FV fans is most often found in the boiler industry. Fans for boilers force ambient air into the boiler, typically due to a preheater to increase overall boiler efficiency. Level outlet dampers are used to control and maintain the system pressure. Typical fan arrangements utilize a wheeled center hung on a shaft with integral inlet boxes. Thanks for learning. If you like this video, please give a like to our channel and subscribe it.